next topic what you are going to see is nothing but AC servo motor. So the servo motor which works on AC supply is called AC servo motor. So we are going to see AC servo motor. So it is having two windings. One is reference winding to which we will be giving AC supply, and another control winding to which we will be giving control voltage from servo amplifier. So it is having a rotor. Now the AC servo motor is having two parts. One is stator, another one is rotor. So the rotating part is called the rotor and the stationary part is called stator. The stator is having two windings uniformly distributed and displaced by 90 degree in space. One winding is called main winding or fixed winding or reference winding. The main winding is excited by a constant voltage AC supply. The second winding is called control winding. The control winding is excited by a variable control voltage which is obtained from a servo amplifier. This voltage is 90 degree out of phase with respect to the voltage applied to the reference winding. The voltage what you are applying to the control winding is 90 degree out of phase with the reference winding. So this is necessary to obtain rotating magnetic field. In order to get the rotating magnetic field, we are making this voltage in the control winding 90 degree out of phase with the reference winding. The rotating magnetic field sweeps over the rotor conductors. The rotor conductors experience a change in flux. So voltage are induced in the rotor conductors. You know, whenever there is a change in flux, EMF will be induced. EMF is nothing but the voltage. Voltage is induced in the rotor conductors. So this voltage circulate current in the short circuited rotor conductors and the current creates rotor flux. Due to the interaction of stator flux and rotor flux, a mechanical torque is developed on the rotor. So the rotor starts moving in the same direction as that of rotating magnetic field. So due to the interaction of stator and rotor flux, a mechanical force or torque is developed on the rotor. So the rotor starts moving in the same direction as that of rotating magnetic field. So this is nothing but the speed versus torque curve of AC servo motor. Here EC1 is greater than EC2, EC2 is greater than EC3 and EC3 is greater than EC4. Its slope is K2. This is a control voltage versus torque curve of AC servo motor. Here omega 1 is less than omega 2 and omega 2 is less than omega 3. Okay. So here the slope is nothing but K1. Now we are going to find the transfer function of AC servo motor. So let Tm is a torque developed by the servo motor and Q is the angular displacement of the rotor. W is nothing but d theta by dt. It is nothing but the angular speed. TL is the torque required by the load. J is a moment of inertia of load and the rotor. And V is a viscous frictional coefficient of load and the rotor. And EC is a control signal. And K1 is the slope of the control phase voltage versus torque characteristics, and K2 is a slope of speed torque characteristics. So torque developed by the motor Tm is equal to K1 EC minus K2 into d theta by dt. The rotating part of the motor and the load can be modeled by the equation given below. So this is from the mechanical system of a motor. We can write the differential equation. At equilibrium, the motor torque is equal to load torque. So this is load torque and this is a motor torque. So you can equate these two, and so you will be getting J into d square theta by dt square plus B into d theta by dt is equal to K1 into EC minus K2 into d theta by dt. On taking Laplace transform, we will be getting J into S square into d theta, theta of S plus B S into theta of S is equal to K1 into EC of S minus K2 into S into theta of S. From this, you bring this minus K2 S theta to the left hand side, and you take theta of S constant common. So you will be getting J S square plus BS plus K2 into S into theta of S is equal to K1 into EC of S. So theta of S divided by EC of S is equal to K1 divided by S into JS plus B plus K2. So we are going to, from the denominator, you are taking B plus K2 common. So we will be getting JS divided by B plus K2 plus 1. Now, instead of this K1 divided by B plus K2, you are writing it as Km, and instead of J divided by B plus K2, tau m. Okay, you are writing. This Km is nothing but motor gain constant, and tau m is nothing but motor time constant. Km is a motor gain constant, and tau m is nothing but the motor time constant. Now we are going to see the advantages of AC servo motor. So the cost of AC servo motor is low. It is having high efficiency, and the maintenance of AC servo motor is also less. Disadvantages of AC servo motor is it is having non-linear characteristics. Control of AC servo motor is difficult. So application of this AC servo motor is, it is used in instrument servo, that is in the control pen of XY recorders. Similarly, it is used in computer related equipments, in disk drives and tape drives. We are using this AC servo motors. So we have studied the construction of AC servo motor, its working. We have calculated the transfer function of AC servo motor. Then we have seen the advantages, disadvantages and applications of AC servo motor.